Simplifying negative exponents. So now I'm actually going to go through each one of these examples and rewrite them without negative exponents. For the first one, x times y to the negative fourth. The y to the negative fourth is our only negative exponent, so that's the only thing that's going to change. So we end up with x cubed times y to the negative fourth is the same thing as 1 over y to the fourth with the positive. If I multiplied these together, you could say that x cubed is the same thing as x cubed over 1, and so to multiply fractions you just multiply across. So what we end up with is x cubed in the numerator over y to the fourth in the denominator. So if we move down, the next one we have is 6x squared y to the negative third. So the only thing with the negative exponent is the y to the negative third. So that gives us 6x squared times, and then y to the negative third is 1 over y cubed. So again, if I try to multiply across, I put that over 1, and if I multiply, we end up with 6x squared in the numerator and y cubed in the denominator. So we could, in theory, skip the first step of what I wrote, and just that if there is anything with a negative exponent, what I'm really doing is bringing that to the denominator. So now if we look at the third one down, the only thing that has a negative exponent is x to the negative 2. So the 6 just has an implied 1 as an exponent. The y has a just implied 1 as an exponent. Neither of them are negative, so you're going to leave the 6y alone and only bring the x down to be x squared. So that gives us 6y over x squared. So the main thing with negative exponents is to only apply that negative exponent to its actual base. So a lot of times here, I'm just going to circle this, is we'll want to bring the 6 down as well, but the 6 is separate from the x to the negative 2. So that's why we leave it alone. Just going to box off all the answers here. If we keep going, let's change colors. 10x to the negative 1. So in this case, the negative 1 actually goes with both the 10 and the x because of the parentheses. So the 10 and the x have the exponent of negative 1. You could even rewrite it if you distributed that exponent. It's 10 to the negative 1 times x to the negative 1. So in that case, you move everything to the denominator. So you have 1 over 10 to the positive 1, which I'll just leave as 10, and x to the positive 1, which I'll just leave as x. Then the last one in this row, this time only the x has the negative 1, so that's the only thing that's going to move. So I'm going to write it as 10 times 1 over x, which really just simplifies to 10 over x. So let's move to the second column. So negative 6x to the negative 2. So the negative 2 means move to the denominator, so we end up with 1 over negative 6 to the positive 2. And this one, since we're dealing with actual numbers here, we could simplify to be 1 over negative 6 times negative 6 is positive 36. So it's 1 over 36. As opposed to the next one, negative 6 squared. So since the negative is not inside the parentheses, then really the only thing that gets squared is actually the 6. And this becomes negative 36. The negative in front, it's almost like saying negative 1 times 6 squared. So we apply the exponent first, 6 squared, and then if you multiply that by negative 1, we get negative 36. The next one, x to the fourth over y to the negative 2. So if we have a negative exponent in the top, we bring it down. So if we have a negative exponent in the bottom, we bring it up. And that gives us x to the fourth times y squared. If we have a negative exponent and it's outside the fraction, you could distribute it in like we did before, which would give us 2 to the negative 3 over b to the negative 3. And then because each one is negative, we're going to bring the 2 to the negative 3 down, and we're going to bring the b to the negative 3 up, which is going to give us b cubed over 2 cubed. Or, if I can squeeze it in here, b cubed over 8. And then I was also going to say with this, you could actually, because a negative exponent brings things from the top to the bottom and the bottom to the top, you could actually rewrite this by just flipping what's inside, b squared, and then changing it to a positive 3 exponent and working from there, because then if I distribute that, we get b to the 3 over 2 to the 3. And we'd get the same final answer, b cubed over 8. And then for the last one here, let me get a different color. I'll just stick with red. We're just going to move everything that has a negative exponent. So this is going to have to get moved. It's in the top, so it's going to have to go to the bottom. This has a negative exponent, so it's in the bottom, so it's going to have to move to the top. X to the negative 2 is negative, so that's going to have to move to the top. And the 2, remember, is separate from the x to the negative 2. That's 2 times x to the negative 2. So the 2 stays exactly where it is. So if we do that, okay, the 2 is going to stay at exactly where it is, and everything else is relocating, essentially. So the x to the negative 2 becomes x to the 2 up here. Y to the negative 3 is y to the positive 3 up here. And z to the negative 1 becomes z to the positive 1, which I'll just write as z in the denominator.